start. Okay. And last class, I remember we are getting close to complete this section. So, so anyway, so we already know the CSV file. We read the CSV file and we use the name column from one of the column of the CSV file as the index. And for Pandas, the major two data structure that we discuss is series and data frame. And the series is one dimension and the data frame is two-dimensional. So for two-dimensional data frame, so we have index. So we have kind of row and a column. And for row, you can have label, named label. For column, the same, you can have label, named label. So that's one of the difference between series data frame and NumPy. NumPy, you can only use positional index. And here we can also have label index. So named index. And the last class, we also learned a couple of methods to select a certain item or section of items. And we can directly use this as a user, like a comma and a colon, etc. And we can also use dot log. And dot log, it use named label. And we can also use .ilog. And .ilog, it use position. Okay, use position. Okay, so that's just a quick review of the concept. So we know this, and then, so regarding this data frame, so this is a data frame, and we can locate the row. Is it just specify? So this is also named. So you gave the index and index this index a name. So the general name for all of this index, because in data frame, you can also support a multi-level indexing. Okay, then in that case, if you name each level of index, and it will be easy to manage the data. So here we call the dot log, okay, and then you can specify the name of the name of the row. Here, same again, the second row, you just gave the name, okay, and so dot log, we kind of get, and here, and the dates it's in previous, so probably here we have the output of the dates. Yeah. So let's take a look again. So this is another data frame, DF. It looks like this. So for the row index, it's date time. It's date time. So that's, and date time, previously we save it in a series. So this is a series. And it is used as a named index. And this is 6 by 4, okay. And this is the first item of the series, okay. So we get this. And the same thing, you can use the dot log to get the first row, okay. So that's how we get the output of the first row. And here, the next part is selecting multi-axis by label, okay? And we kind of already see quite a lot. So the dot log, and here we have colon before colon. So this is the first dimension, so axis is 0, and this is for axis is 1, okay? And for the first dimension axis is 0, we do slicing. Slicing everything, okay? And for the second dimension, so axis is 1, we do indexing. So for both here, we use the named label, okay? And what next one shows is dot log. So it's similar as we do. The first is slicing, you specify, okay? And when you use, and also be careful when we use named label for slicing, if you take a look. So it's included, okay, and both A. And here is indexing, so it's included, not like previously when we just do, if you just do DF, like this, and it's, if you don't use a label, that if we don't use a label, then it's exclusive, okay? So there's some subtle difference. And you can also use the slicing and the indexing to reduce dimension. So that's what here shows. So what over here is we select the first row, that, and then the 2 columns. So then the data is reduced. It just got 1 dimension instead of 2 dimension. And you can also get a scalar value. So you specify, so you just get a single item. Okay, so here we call it a scalar. And there is another one we haven't learned, the dot at. So we learned the dot log and dot I log. And here we also have dot at and dot I at. Okay, and generally speaking, it's for fast access. If you want to, so accessing fast, you can use at or I at. And similar, for at, it's using label. And for I, it uses position. Okay, positioner is by the default position. Okay, and the I log. So the I log is position. Okay, so using position. So this is the third one. Okay, the third one. And we can also use position to do slicing. Okay, and here it shows. As it here shows. And then let's take a look at the result. And if you take a look at the I log, is it I log when you do the slicing, it's excluded. So 0, 1, this is excluded. Exclude. So there's some subtle difference. Okay. And you can also use position to do indexing. That so here is okay. I select second row, third row, and the 5th row, and the first column and third column. This is for both axes. Both axes that we do indexing. We do indexing. So then you just locate a specific item. And here it also shows you can also slice in row. If you slice in row, then the first dimension. So before comma, you do slicing. And for the second one, you include everything. So this is to this is every columns. And you can also do just slicing column, that certain columns. And then in this case, then before comma, it's just a colon. And previously we said the at and I at, is it? So it's faster, okay, compare with lock and I lock. So if you want to faster access, you can also use at and .I at. Okay, so that's regarding, so we discussed .lock, .I lock, and .at, and .I at. Okay, and both can be used for slicing. And for slicing, remember using colon, okay, and then you can also for indexing. Okay, indexing. And the separated multiple axes, it's always using comma, okay. So something, so depends, okay, using comma. Okay, so that's all. Then the next part is Boolean indexing. I remember in NumPy, we also kind of discussed this idea. So here, let's see the Boolean indexing. So here's a data frame, is it? And you can use dot a column name, is it? And then it said, okay, for that specific column, all items greater than 0, and I'm going to take it. So it does filtering kind of. So we can use Boolean indexing to do filtering, okay, to do to select a certain item that meets the conditions that you defined. And over here, what it shows is within your data frame, if the item is greater than 0, then you're going to select it. Then the result does should only give you positive. Then for all of the negative, it just return the null value. And we can also use this for filtering is in, okay, to do kind of the membership check is in, okay. So here, if you recall, this is deep copy, okay, so it won't impact the original. And then we are going to add, because the original has A, B, C, D, is it? And then here you add a new column E, is it? So you can just, so this is a list, you assign it to the new column. So this is also kind of, you expand the column, is that you just give a new column name and then of the values for the new column. And then if let's take a look at this part. So this is regarding that column, that is 1, 2, 3, 4, 3, that is the item. Then it said call that is in. Okay, within is in, you plug in here as a list. So you want to get off the item that has 2 and 4, is it? And so that's the condition, is it? After condition, then, so basically this will return true, false. Is it? So it's a Boolean. This part, you get the Boolean result, is it? So Boolean result, if it's true, then you are going to select all of the items. So that's how we come up with this two, because it's 2, 3, is it? Yeah. So 2, 4. So it's this specific 2 rows. So then it just select those 2 rows. So here we can see you can also use this is in to do filtering. And then let's see, you can also change the value. Okay, change. So here to give us a series, pandas here. And this is the index. This is the index. And this is date time index. And then if previously, if you recall the DF only has A, B, C, D. It only has A, B, C, D. And the F, these S1s, we just create a series. So you add a new column, a new column, F to this series. And for the S1, if you take a close look, S1 started at January 2nd, but the DF started at January 1st. So can we do that? Yes, it's very flexible, you can see. You can still add the S1 to data frame DF. It's just whatever the missing value, it just automatically filled with the nav values. So that is fine, okay. And we have that DF, is it? Then if you want to locate a specific item, so this is using label indexing to find the item, is it? Then you reset it to 0. So you can also set a value, okay? That's just what this part means. And we can also using position, okay? So here is the first row and the second column, this one, you assign it to 0. So you can also reassign, okay? So that's also allowed. Okay, and what next one try to show us is, we can also set as by assign value with NumPy array. Yes, so this is slicing and indexing. So basically it's just that, okay, regarding all column D, is that all column D, then what you're going to do? You're going to have, be careful, okay, so this is one element NumPy array, okay, one element NumPy array. And also in Python, be careful, the multiplication. Here in this case, it's not a multiplication, this represent repetitive. Okay, repeat this item certain number of times, so depends on the length of the data frame. Is that so this is 6, so you're going to repeat this item 6 times. That's how we have 5, 6. Is it 5, 6? So you have kind of like a list that has 6 of 5, and then you add you reset a column's value. Yes, so we did a reset. Okay, so it's you can also assign an array using an array to do the setting values. And what next one try to show is we can also combine the filtering and with setting. Okay, so you filter all of the positive value, then you negate it. Then you negate. So if it is original positive, then you negate it. That's what this shows. So we can also borrow this. Okay, the next one is regarding missing value. Okay, missing value, generally speaking, that nets from NumPy, okay, to represent any missing values. So over here, there is another function called reindex. It's a reindex allows to change and delete the index on a specified axis. Okay, so let's take a look. So here is that data frame. Is it so the data frame DF looks like this. It's A, B, C, D, F. Okay, A, B, C, D, F. And the original has 6. So this is 6 by 5. Is it 6 rows and 5 column? Okay, 6 rows, 5 column. And for this, it says, okay, df dot reindex. Okay, reindex the index. The index, it take dates 0 to 4, etc. So basically 4 rows. And then it says a column. Column is the original df's column. Original df's column is A, B, C, D, F. Is it? And here I add another one called E. Is it? And then what it does is, so there we can have this df1, okay? And regarding this df1, then you call that data locate, and you reset the first 2 items to E, oh, not to E, to 1, originally E. Because over here, you just add the column, but you didn't provide a corresponding, so we added column E, is it? But no values assigned. That's also fine. And if no value assigned, we'll take this NumPy nav values, is it? Then you specify, okay, the specific item, I want to set them to 1, okay? And then we can take a look at this result, df1. Yes, is it? Did you see? So it does add the corresponding, just pick the corresponding rows, and then it update this to as 1, okay? And for missing values, we can call drop NA, is it? Drop NA, then you can specify how you want to drop any, or you provide a certain condition, is it? So you can specify the how, okay? And here's any. So if there is a nav values, you're going to drop. And then let's take a look, the df1. So this is our df1. This is a df1. df1, is it? So we have nav, nav, we have 3 rows of nav, is it? That's why here drop NA, is it? Then you say, okay, if there is any, I'm going to drop. Okay, I'm going to drop. So that's why you only get this single row left. Okay, so deal with missing value later on in machine learning. We will use quite often, because a lot of time in the real world, the data, it's not perfectly filled. They may have some missing values. How do we deal with it? So you can drop. You can also provide some values to fill. So here says, okay, if it is, then we fill it with certain specific values. So you can also do this, fill NA. And a lot of time in machine learning, you can use like the mean value to fill. And we can also call that is NA function, okay, and what this will return, you get a Boolean values, is it? So we get all of the Boolean values. And what next part try to show us, we can also do some like mean summation, like those statistic descriptive values, okay? And generally speaking, when you apply arithmetic operations, that generally we should exclude some missing data. Anyway, so over here, this df mean, is it? And over here, we didn't specify. So not specify axis. And whenever you do mean or summation, is it this is a 2D one, is it? So 2D one, and also for data frame, for Pandas data frame, the data is heterogeneous type. So for heterogeneous type, so we prefer like you specify the axis, is it? And here we didn't specify, so by default, it is axis is 0. Axis is 0 is what? It's a row, is it? It's a row. But a row, you have column, is it? So a long column over here, column. A long column, is it? So that's why we have the value for each column, is it? For each, but you vertically add all of them, is it? So you have the sum, basically sum over row, and then divide the number of the number of rows. That's we come up with this mean. So you have a value for a specific column. Okay, so that's mean. And over here, you can also specify axis. So here's specific, say, okay, axis is, so this is by column. So it's going to do addition first, is it? And then do divide by. So you're going to sum all the column. So that's why the result we get is by row, okay? So each row, you have a result. And what this next part, it's also broadcast, okay? And we already learned that from NumPy, so similar concept. So here we have the series, and the index is data frame. You can also call the shift. Sorry. And we over here we call shift. And when you do shift, if you take a look, initially one should start at the first, is it? Because you call shift 2, so it's a push back. Is it? So it's a start at the third one. Okay. So this shift is a function. What next to try to show is, and I remember previously we also kind of learned this concept, okay, a broadcast. So here it calls the sub. This sub is subtract, okay, so arithmetic subtract operation. And DF, this is a 2D, is it 2D? And this S is 1D, is it? And then we are going to do the subtraction. Okay, subtraction, the DF subtract this series S, and we also specify the axis is index. Okay, not the second dimension column. Then in this case, if you recall that S, the first two are nav values. So this is the original DF. This is DF, and the S is first two are nav, is it? And then it has some values. So over here it's going to do subtraction, is it? A subtraction. So the result we can see, because the first two are nav, is it? So it do the subtraction for each one of it. Okay, for each one is for the index, is it? And because the first two is nav, so then you have nothing. So when you have value, the other you don't have, so then the result is also nav, is it? So that's, and also it's applied to every column, is it? So it's a broadcast. Okay. And over here, it also says we can also apply function. You can also apply function called apply. Okay, so df is a data frame object. Okay, and this object's method is called apply, is it? And then you can plug in method, plug in a function. So this function is NumPy's cumulative summation. Okay, cumulative summation. And here we didn't specify the axis. So the default one is the first dimension. Okay, first dimension. So do cumulative summation. So cumulative summation is adding on top of the previous addition result, is it? So, and over here, if you take a look, yeah, it does this, is it? So this is still get this one. And then for the next one, what we get is, so it's a change, is it? So it's built upon, okay. And then from this, you add this, is it? So that's how we come with the next one, okay. So this is cumulative summation. And we can also, so the function, if there is a named function, you just plug in. Is there sometimes you just want to use some kind of like inline, no named function, so then you can use a lambda expression. Lambda expression, and here is regarding some value, is it? And then you say, okay, call that object's max minus its minima. Okay, so that's what we want. And here we didn't specify axis. So no axis specify. So by default, its axis is 0. Okay, axis is 0, so it's what? It's a long column, but do the summation or the operation. So it's row by row in this case. Is it row by row? So for each row, you find the maximum. Not for each column you find its maximum and its minimum. So it's over all of the row, but for the specific column, that's why you want to know the difference. Okay, and what the next one try to show is kind of like a histogram. Is it? So anyway, so there's some random number for a series, is it? And if you want to do some kind of value counts, there is a method in Pandas, it's called value counts. Okay, so the result is, okay, 2. 2 is from this random number. How many 2? This random number generated 3. So 3 2s. Okay, and the 4, 2 4s. Is it? And 2 1s. Is it? So it gave you how many each of the item you have. Okay, so that's value counts. You can also do that. And the string method, we are going to skip that. Okay, so if you are interested, you are very welcome to study these notes. And you can also check my previous semester's video if you're interested. But we are going to skip. Next section is about it's about merge, and that's quite useful, okay, because for the data set, sometimes you will not just get a single data set. You may have multiple data sets, is it? So multiple data frame created. Suppose maybe from different CSV file. Is it from multiple CSV file, and each one there has a data frame, is it? And then maybe you need some way to merge them, is it? So Pandas also provide facilities to combine together series and data frame. Okay, data frame. And there are a couple of functions. And the first one we are going to learn is called the concat method. Okay, concat method. So let's take the first one, it's quite the same. So this is a data frame. You create data frame, some random number, is it? And it's 10 by 4, 2-dimensional. It's a 10 row and 4 column. And then what next we do is we do slicing. And then you comma, is it? So this is a list, is it a list? And within the list, you have some 2-dimensional data frame. So that's fine, is it? Okay, so this is an object, pieces. And then you want to get all of them together. So then you can call this concat, the pieces. So over here, you plug in is what? Is a list. Is it list, a list of data frames? Is it? Okay, and the result does show us, is it? And what next one try to show? So previously we also learned that the data frame can also be created from dictionary. So here we have this 2 dictionary, and then we call data frame to convert to dictionary and specify the index. Okay, and here we output those 2 data frame. We can take a quick look. So this is the 2 data frame. The 2 data frame. 2 data frame that's created by dictionary. Okay, then so we kind of have some idea, is it? So anyway, so that's index. Is it? So the first index start from 0. Is it? So this is index. The second index is starting from 2. Okay, those start from 0. And we call concat. So pandas.concat. And then you provide the data frame as a list. And then you also need to specify the axis. And you can also specify the join method. So inner join, outer join, left join, or right join. So how do we join? Is it? So inner join is kind of you looking for intersection from 2 data set. Is it? And this concatenate axis. And if we take a look, both are not exactly the same. There's a name, age, address. So this 4, both have. But the last column, the first one has mobile number, second one has salary. So these 2 are different. Is it? So this axis is second dimension. So basically the idea is you are going to expand. Is it? You are going to add more columns. Okay, but it's you are going to concatenate. Concatenate, if you take a look, so this is kind of like the database join, is it? And they use a primary key, is it? Use the key for looking for join. And here, basically, this index kind of serve like the key concept. Okay, so when you do inner join, you're looking for the commons. The commons, this 2 has a commons, is it? And George and Bob. George and Bob. Is it? So it's kind of that's so the result, if you take a look, so this part repeat the first one, is it? And you do get the intersection, the inner join. the inner join parts. But we do get the new column. There's a new column, and overall the column expanded. Okay, so that's a concat. And of course, you can also expand the row. Okay, then you specify it's 0, and you can also specify if you want source or not. And if we and over here, we didn't specify the join. So if you didn't specify here, and because here is by row, is it? So there is no intersection concept. Is there no intersection concept if you take a look? So it's just, so this is the first one, and this is second one. So even though these two have the same index, but here we still keep the second one. Okay. And we also add, and did you see in this case, the column is not expanded. So the repetitive ones, they will share. And if the other one doesn't have, then you're going to expand it. And you can also call the concat, it's similar. So here is axis is along the second dimension. Is it along the second dimension? And if we compare this result with this one, is it? This is also concat to the second dimension, but here you specifically said the join mode. Join manner is looking for intersection. Okay, looking for intersection. And let's take another look. It's total records. We have 8 records. Is it? And Jade, Prince, George, and Bob. Here, George, Bob, Drew, and Stephen. And when we just expand the row, we didn't specify. So they do, it's kind of like outer join. Union, okay, include everyone. And here, same thing. Here is you want to join along what? Second dimension. Is it second dimension? If you take a look, then it include everyone. Does it include everyone? So 1, 2, 3, 4, 5, 6. But the record is 6 records, not 8, 1. Is it why? And also here we didn't specify join. So basically this kind of like, even though this is shared, is it? But you are still going to keep everyone. So all data from both sets are going to be kept. But for this two, Bob and George, because they share the same, is it? They share the same. So you're going to combine them. Is it combine them? And for all the others, is it like so for Jade and Prince? Is it? And from second one you don't have. Is it? So that's why when you do join, it's all provided with nav values. And same thing here for Drew and Stephen. It's all filled with nav values. So when you do, so this is a kind of like a union, is that you include everyone. But if some value doesn't exist, then you just provide as the nav values. And over here it's also, if you don't pay attention, it's a lot like the previous one. But here, be careful. It says join axis. So it also specify which axis you want to be count on for the joining operation. Is it? So it says this is the first data sets index. Using that as a joining index. Then let's take a look at the result. If you take a look at the result, So Drew and Stephen not included. Not included. Is it not included? And you have all of the index from the first data set. Index. So the first kind of like the left one. So this kind of like left join. Okay, later on we will see. But you do expand of the columns. Is that if there is no values, you just provide the nav values. So this kind of look like, you know, this is the first one, is the first one. And the second, they have some common things, is it? But of course, here you expand, is it? So something over here previously you may not have, then over here you provide like the salary, is it? The salary part. So it's mostly based on the left part of the data set. So it also has some similar concept like the mass set. So for the join, you have like a nature join, basically it's inner, is it outer join, left outer join, or right outer join, okay? And when we specify, you specify using argument how, and then equal sign, and then you specify, okay, so how and outer, how and left, how and right, okay, this concept. Okay, then next, let's take a look. So here we have the data frame, two data frame. It shows, looks like this. And this time, instead of concatenate, we call the merge. Okay, and we call merge, and then you merge both data frame, and you can specify on what. Okay, and here, this key, this is a column name. So you can also specify when you do the join, is it to do the merge, on which column you are going to merge, okay? And if you take a look at the result, you will see that, and you have both new, but this one, it's the shared, okay, it's a shared. And it also repetitive, repeat, so that you will be aligned with. Okay. And what is the next one called the merge? And here you have two new data frame, okay? And this time the key part exactly the same, okay? It's just the other column different, 1, 2, and 4, 5. And we still do that. Then in this case, you will have this kind of result. So it depends also on your data set, okay? And the dictionary, we already know that. And this time, if we take a look at both data set, key and the key one, both are columns. And we call merge, is it? And you can also specify using multi-columns for the merge, okay, for the merge. Then let's take a look at the result. This is also like, we didn't specify, is it? We didn't specify its join mode. And here it takes the inner join. So it looks for the common ones. So both has this and K0 and K2, K0, is it? So they expand the column based on the common specified keys. And what is the next one try to show here is you can also specify left the how, is it? And be careful, this is the left outer join. Outer join and on key, is it? Okay, so left, who is left? This is left. The first data frame, is it? It's left. Okay, so it's based on df's key and key one. So that's how you, so all of this come from df's. Okay, so you can see df1 is then not included. Okay. So it's not included. Okay, and you can also specify the merge, is it and on key and how it's outer, is it how it's outer, and then over here it's kind of sort of like the union concept. We get everything. Okay. Okay, I think I run out of time today. Run out of today.